All right, so this is 5.2. Basically 5.2, you're going to be adding and subtracting polynomials. There are some things on the PowerPoint that I'd like to review with you guys. All right, so just kind of reviewing some, what we would say, vocabulary with polynomials. So this is a polynomial that's just multi-term. So what we call these things are terms. So this polynomial actually has 4 terms, and what separates terms is a plus or minus sign. So when I'm asking you how many, you kind of start from the left. If I'm asking you how many terms you are, once you've hit a plus or minus sign, so this will be 1 term, there's a plus or minus, 2, there's a minus, 3, so there's 4 terms. And we say a term that does not have a variable with it, we call that a constant. Okay, so there's 4 terms. It kind of breaks down the 4 different terms for you. And then the coefficients, remember coefficients are the numbers in front of the variables. So the coefficient to 7x to the 5th would be 7. And this is the one that sometimes we forget about. So when I say, what is the number in front of this x squared, y squared? It's a 1. They always, even though you don't see it, the number's there. And it's not something that, that if it is a coefficient of 1, you usually don't see it. And so it's a good habit to get into, not to put that 1 even in your answers. And then negative 4x squared, the coefficient is negative 4. And 7 is what we call a constant. So it's just 7. 7 is the constant term. Now the first, I think it's maybe the first couple problems, or maybe it's in the first problem, it talks about the degree of a polynomial. And it's really easy to solve this, but it's just kind of different. It's kind of new, so some people get confused by it. So each term has a degree. And the way you determine the degree is you count their variables, how many variables they have, how many exponents they have. So each term. And then when it says the degree of the polynomial, it's going to be that highest term. Okay. So in that one example, and I have an example ready for you guys, but you would check the degree of each of the terms, and then whichever is the highest, that would be the answer for the whole polynomial. Like I said, we'll do an example and we'll get to that. So you have special types of polynomials. If it is just one term, we call that a monomial. 2 terms, we call that a binomial. And 3 terms is a trie. After that, we just call it a polynomial. Okay, so there's really only 1, 2, or 3 that we have a special name: monomial, binomial, trinomial. And then if it's more than that, we call that just a polynomial. So when you're, let's just go right into that first example. All right, so it wants you to find the degree of the polynomial, and then determine if it's a monomial, binomial, or trinomial, or none. So it's either 1, 2, or 3, or if it's more than that, it's actually what we call a polynomial. So let's first determine the number of terms. Remember, what separates terms is a plus or minus sign. So if we're counting terms, we got 1, then I hit that plus sign. 2, hit another plus sign. 3. So I have 3 terms. If something has 3 terms, it is called a trinomial. Okay. 1 term, again, monomial. So if it was just that 1 term, we'd call that a monomial. 2 terms, we call it a bi. 3 terms, a tri. Okay, so that's that. The first part of it is find the degree. So let's talk about the degree. So each term has its own separate degree. And then when it says find the degree of the polynomial, once you determine each term's degree, it's whichever one of these is the highest is what you use. And again, what you're doing is you're counting exponents, okay? So even though we don't see this, this is 1. So how many exponents total? There's 1 here, 5 here. The 7 doesn't matter. So altogether, there's 6 exponents. So the degree of this term is 6. Let's count this one. There's 2 here. Again, the coefficient doesn't matter. 9 doesn't matter. There's 2 z's here and 1 x. So the degree of that term is 3. Now that's how many variables do we have here? We have 7 z's and 2 x's. So altogether we have 9. So that term has a degree of 9. So when they ask me what's the degree of the polynomial, it's the highest one. So what's the highest one? The highest term is 9. So the degree of this polynomial would be 9. All right. So, and again, there's only 1 or 2 questions that kind of deal with that, but it's something you will have to know. Once you kind of get it, it's not that hard. All right. So the next example, and pretty much what we're going to be doing in 5.2 is a lot of adding and subtracting of polynomials. Okay. And we'll kind of review each of these kind of terms that deal with that first example. So how many terms do we have in this first parentheses here? We have the negative 12x and the 10, right? So we have 2 terms. This is called a binomial. Come over here, we got x squared, 12x minus 8. So this is actually 3 terms. This is called a trinomial. Not so important on this because that's not really what we're doing to solve this, but it's good to review it. So what you're doing is you're adding these 2 together. And remember the rule, and normally the way I'm going to do all these, I'm going to use what we call vertical addition. And adding, we don't have to change anything. But remember, when we are subtracting, we've got to add opposites. So we'll do some subtraction problems as well. But I'm always going to pick whatever term is, whatever's largest. So if I have a trinomial, I'm going to put that trinomial on top. Okay. And then I'm going to write the like terms underneath each other. So the negative 12x, I'm not going to write it under x squared because that's on its like term. Its like term would be the 12x. Then I have a plus 10. I'm going to write it under the other constant as well. So these are what I'm adding together. There's nothing to add to the x squared. That just comes down. Okay, and hopefully you recognize here a plus 12 and a minus 12. These are actually going to cancel each other out. So I don't write 0x. They're just gone. Okay, and then a negative 8 plus 10 would give me a plus 2. So my answer would just be x squared plus 2. And I can leave all that spaces, okay? So that would just be the answer to that problem. So let's look at a subtraction problem. So this would be the problem that would be on our computer screen. What I would do is I would not even write, when I write it down on my paper, I wouldn't write it down like this because I would change this into an addition right away. So again, I don't mess with the first parentheses, but the minus I would change to a plus. And remember, what is that going to affect in here? It's going to make both of these opposites. It's almost like you're taking a negative 1 and distributing it into that. So if it's easier to think of it that way, that's fine. But again, the 11x squared is going to turn into a negative 11x squared. The negative 5, the opposite, it would turn into a plus 5. So again, if I see this problem on the computer screen, this is what I'm going to be writing down on my paper. I'm just going to change it right away to an addition problem. And then I'm just going to do it vertically. The x squares we can combine. And some people will do it horizontally. I like to do it kind of vertically. There isn't an x term, so I didn't need to write an x term there. So I'm putting my like terms underneath each other. So I know I can combine these. 5 plus 11 would give me 16. Negative 11x squared plus 2 would give me negative 9x squared. And that would be my answer. So the only thing I have to do different with subtraction and addition is in addition, I didn't have to change anything. Okay, in subtraction, whatever polynomial is following the subtraction, I have to change all of those. Let's do another example. I think this one, the way it was set up was vertically. But again, it is a subtraction. So if this was a problem on the computer screen, that's not really what I mean, if you want to write it down, you can. But I'm going to change that subtraction to an addition. And how does that affect everything in here? Following this, I have to do the opposite, 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 okay? So positive 11z squared will turn into negative 11z squared. Positive 3z will turn into negative 3z. And then the negative 10 will turn into a positive 10. And now I'm just adding. In the way I have it set up, my like terms are on top of each other. This would give me a negative 5z squared. This would give me a negative 15z. And then this would give me a 17. All right. So remember, subtracting is just adding opposites. So there's actually going to be multiple polynomials in this one. All right, so we have a 3x squared plus 9x minus 9 plus 5x squared plus 4x plus 14 minus 8x squared minus 15. So what I would want to do, and eventually I'm going to reset this vertically, is change this to all addition. So I got additions here, I don't nothing to worry about, but that one right there has to be changed. Okay, so that subtraction turns into addition. That 8x squared will turn into a negative x squared, and the minus 15 will turn into a plus 15. All right, so I'm just rewrote this little part here. So now it's all addition. So I'm going to set this up vertically with my like terms underneath each other. 5x squared plus 4x plus 14. And then the last, remember, this was a trinomial, this was a trinomial, this is a binomial, only two terms here. So the negative 8x squared is going to go where I have my other x squares, and my plus 15 would come down with the constants. So that's really good. When we make a mistake on this stuff, and I'm adding all of these, it's just not putting your like terms in an appropriate spot. So again, 3 plus 5 would be 8, but then I'm subtracting 8, right? So it's 8 minus 8. So what's going to happen to all these x's? They're going to cancel out. 9 plus 4 gives me 13x. And then I'm adding these together. Probably add these 14 and 15 together, give me 29. And then it's 29 minus 9 will give me plus 20. So that would be the answer to that type of problem. And then the only other thing I would just want you to watch out for, they actually sneak in a multiplication problem. So it looks like this. Now you may think, whoa, don't I subtract these two? Again, I think on the top it just even tells you, it says multiply. So that's kind of the first hint. The second hint is that subtraction sign is inside the parentheses, not outside. Okay, so remember, if you look at all these other examples, that subtraction sign was outside the parentheses. So when it's written like this, what are these two things doing to each other? Even though you don't see it, they are multiplying each other. Okay, so again, you start with the coefficients, and there's a negative 1 there. So 14 times negative 1 gives me negative 14. And again, the bases are both x's. So what's the rule when you're multiplying exponents with the same base? You keep the base, add the exponents. 3 plus 5 would give me 8. So that would be the only thing you just got to watch out for. All the rest are basically what the examples that I just did, adding and subtracting polynomials. And then understanding, like I said, the degrees of the polynomials as well.